Today we will learn about decimal expansion of real numbers. Subscribe the channel and press the bell icon to get latest updates from LearnFatafat.com. If P and Q are two integers and Q is not 0, then numbers which can be expressed in P by Q form are rational numbers, and the numbers which cannot be expressed in P by Q form are irrational numbers. The collection of rational numbers and irrational numbers is called real numbers. It is denoted by R. Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now. Consider rational number 9 by 4. Let's try to represent it in decimal form. For that, we divide 9 by 4. Here it is clear that 9 is not completely divisible by 4 as 9 is not a multiple of 4. If we divide 9 by 4, then the quotient is 2 and remainder is 1. Here we put a decimal point after dividend. We can write as many zeros after decimal point as we want. So, we write a 0 after it. Bring down this 0 so the remainder becomes 10. In quotient as well, we write decimal point. Now we divide 10 by 4. So quotient is 2 and remainder is also 2. Again, we write a 0 at hundredths place after decimal point in the dividend. Bring down the 0 to the remainder. The remainder becomes 20. Divide 20 by 4. Quotient is 5. So, we write it at hundredths place in quotient. Now, we get remainder 0. So, we will stop here. So, the division of 9 by 4 is represented as 2.25. Look at this number. This number has finite number of digits. Such a decimal form of rational number is called terminating decimal form of the rational number. Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now. Let's take another example. Let's try to represent minus 4 by 5 in decimal number. First, we ignore the negative sign and divide the numerator 4 by denominator 5. In the same way, we divide 9 by 4 in earlier example. Here, we can't divide 4 by 5. So, we put a 0 in quotient. Now, we put a decimal point after the dividend and write a 0 after it. In the same way, we put a decimal point after the 0 in the quotient. Now, ignore the decimal point of dividend, so the number becomes 40. Now, we can divide 40 by 5 easily. 8 times 5 is 40. So, write 8 after the decimal point in the quotient and subtract 40 from dividend. By doing so, we get remainder 0. Here we stop. So, the decimal form of 4 by 5 is 0.8. But since the number is negative, hence we put a negative sign before the decimal number. That is, the decimal form of minus 4 by 5 is minus 0.8. This decimal number is also a terminating decimal number. Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now. Now, consider a rational number 10 by 3. Let's try to represent it in decimal form. For that, we divide 10 by 3. Here it is clear that 10 is not completely divisible by 3 as 10 is not a multiple of 3. If we divide 10 by 3, then we get quotient 3 and remainder 1. Here, we put a decimal point after dividend and write a 0 after it. Similarly, we put a decimal point after the quotient. Now, bring down the 0 to the remainder, the number becomes 10. Dividing 10 by 3, we get quotient 3 and remainder 1. Again, we take a 0 at hundredths place. Bring it down. Again, remainder becomes 10. Dividing 10 by 3 again, we get quotient 3 and remainder 1. This is repeated continuously and never ends. It means that the decimal form of rational number 10 by 3 is 3.333333 and so on. Such form of decimal number in which one or more numbers get repeated again and again after the decimal point is called recurring decimal form of rational number.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
To represent this form, we write digits before the decimal point. As it is then, we put a decimal point, then we find the digits which are repeated. Here, only 3 is repeated, so we write 3 after decimal point and put a dot on it. The dot represents that the number is repeated. Remember, we should put the dot only the number or numbers that are repeated. Here is another example. Consider the rational number 7 by 11. Let's obtain its decimal form. Dividing 7 by 11 in the same way, you will observe that digits 6 and 3 are repeated in the decimal form. So, this is also an example of recurring decimal form of rational number. We represent it by writing 0.63 and dash above 6 and 3. All rational numbers which are represented in P by Q form have either a terminating decimal form or recurring decimal form. Conversely, every number with a non-terminating or recurring decimal expansion can be expressed in the form P by Q, where P and Q are integers and Q is not equal to 0. That is, these numbers are rational numbers. Also, note a general observation. If the prime factors of denominator are 2 or 5, only then the rational number has terminating decimal form. And if the prime factors are other than 2 or 5, then the rational number has non-terminating recurring decimal form.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Now consider a famous value pi. Pi is the value of measure of circumference of a circle divided by its diameter. Circumference is the length of edge of the circle and diameter is the length across the circle passing through the center. Independent of how big or small the circle is, the value of pi remains same. It is as given. It is an irrational number as we can't express it in P by Q form where P and Q are integers and Q is not equal to 0. The decimal expansion of this number is non-terminating as well as we won't see any repetition of digit, so it is non-recurring as well. In fact, the decimal expansion of irrational numbers are always non-terminating, non-recurring. Conversely, every number whose decimal expansion is non-terminating, non-recurring is an irrational number. Another similar number is Euler's number. It has value E is equal to 2.71828818284590 and so on.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Now, let's see an example. Check if 2 plus root 3 and 2 root 2 are rational. Consider 2 plus root 3. Decimal expansion of root 3 is 1.73205080,757 and so on. So, 2 plus root 3 is equal to 2 plus decimal expansion of 3. The result is 3.73205 and so on. This number is non-terminating. Further, the digits are non-repeating. So, this non-terminating, non-recurring decimal number is an irrational number. Consider 2 root 2. We write it as 2 multiplied by root 2, which is equal to 2 multiplied by decimal expansion of root 2. The result of multiplication is 2.82842 and so on. This number is also non-terminating, non-recurring decimal number. So, 2 root 2 is an irrational number. So, I hope you got the good information of terminating, recurring and non-terminating, non-recurring decimal forms of real numbers. I hope you understood this video very well. Thanks for watching this video. For more videos, visit LearnFatafat.com.
Like, share and subscribe LearnFatafat.com and press the bell icon to never miss an updates from LearnFatafat.com.